Hello again, this is Mrs. Gabriel presenting to you Chapter 9, Part 2. We are specifically going to go over some of the finer points of groundwater. Chapter 9, Part 2. So groundwater is, as you know, a very precious commodity, and it's a big deal. It's been a big deal for a while because we're polluting it, we're contaminating it, and we're overdrawing from our groundwater resources. We're going to spend a little time looking at why we care about groundwater, where it comes from, and what are some of the advantages and disadvantages of using it. And as you can see from the picture here, you don't want your water coming out of your sink to look like that. You want your water to be clean and pollution free. And there's a lot of legislation and there's a lot of activism going on conserving groundwater for our protection, for human health protection. If you look at the lower picture, the lower right picture, this is just one very common example of how easy it is for contamination to occur in the groundwater. So you see the gas station that's pictured to the left, and the gas station can just have a leak, and that leak might be just in solid material, but all you need is a little crack of that solid material to get into the moving water beneath it. If it gets into the moving water beneath it, it can just flow along that groundwater river, that groundwater path, and get into somebody's drinking well. And the next thing you know, maybe what's coming out of your sink doesn't look like anything polluted, but it certainly can be something that you don't even notice is polluted. So we have a lot of people that are writing books, publishing research, and trying to get the word out that we have to protect our groundwater. Some of the things that you need to know to understand this discussion are: what is an aquifer? What is the difference between an unconfined and a confined aquifer? What is a water table? What is a recharge area? And what are springs? So let's go back to this first picture here. You might want to take notes on this. Write yourself a little note, maybe write in your own words. An aquifer is just small spaces found within permeable layers of rock and sediment where water is found. It looks like in the picture that they're just big swimming pools. So if you look at what's in blue, the unconfined aquifer and the confined aquifer, they look like big blue swimming pools that are underground. But that's actually not the case. They actually have lots of little pieces of rock, and the water's just distributed between all the spaces between the rock. And then if you look at an unconfined aquifer in the picture, the unconfined aquifer is only covered by porous rock. So anything I pour right above it, any kind of contaminated water, any fertilizer, any pesticides, any gasoline, any oil, any paint thinners are going to go right down and seep through the soil, through all the horizons of the soil. Remember your horizons, and leach right through it all and go into the water table. And then all that happens is the well that's sharing the same water table is drawing those contaminants right back into the household. A confined aquifer, on the other hand, is the lower blue swimming pool looking area, which is not. Remember, it's all just little pieces of rock with spaces and pores between them. The confined aquifer has a layer on top of it, and you see that's called the confining layer. That's why this is a confined aquifer. And that rock it could be something made of clay, it could be some other igneous or metamorphic, or maybe some sedimentary rock where water cannot get through it. So if I pour something on the grass way above, it's not able to get to the confined aquifer. Now we live in Harford County, and the people that draw on wells that are using well water, that's coming from, in our case in Harford County, unconfined aquifers. So unconfined aquifers, remember, very easy for anything that's poured above ground to contaminate them. Other things that I'll go over again in the picture are a water table, recharge area, and springs. So this picture here is showing us a spring, and that's just water that comes out of an aquifer naturally. It percolates up to the surface. It can fill in wetlands. Actually, springs are very common for helping fill in wetlands, and wetlands, as you know, are very important spots for biodiversity. And the water table, let's look at this right here. The water table is just that surface area on the top. So in our unconfined and confined aquifers, both of them, that top portion of each of those aquifers is called the water table. And we refer to a water table really because we're talking about the well, we're talking about the streams. So if the water table starts getting deeper and deeper, the well might no longer be in the groundwater. It won't be able to withdraw. If the water table gets deeper, lower and lower and lower because we're overusing it, that spring might no longer be fed from the groundwater. And the stream might no longer be fed from the groundwater. So there's our stream. Okay, so what we're looking at in the region in kind of the red, yellow in the middle is the Ogallala Aquifer, and it is the world's largest aquifer. We love this aquifer. The gigantic Ogallala Aquifer supplies about 1/3 of all the groundwater used in the United States, and it's helped to turn the Great Plains into one of the world's most productive irrigated agricultural regions. The problem is that the Ogallala is basically a one-time deposit of liquid natural capital with a very slow rate of recharge. It is an unconfined aquifer, and like most confined aquifer, and like most confined aquifers, it takes thousands of years for it to recharge. It doesn't recharge just by it raining like a unconfined aquifer does. Let's look back at this picture. So the unconfined aquifer can be filled up just by the stream filling up, and a stream can fill up and flow over very quickly just from a bunch of rain coming in. The confined aquifer, if you look all the way over to the top left of the picture, has a recharge area. That's the only place where the water can actually recharge and refill the aquifer, because remember, it has impermeable rock and material all on top of it. Nothing is coming through anywhere from above, so rainwater can only fill in that confined aquifer through a recharge area. The Ogallala Aquifer, which is the region in both that represented in both these maps, has to be filled in by its very few recharge areas. And as you can tell from these pictures, we are actually using up that aquifer much faster than it can be replenished. So looking back at this map, this is an example of not just the Ogallala, which is mostly that region in that red in the middle, but we have other groundwater areas, aquifers, that are also being depleted. So if you look at the red is where major depletion, high amounts of groundwater overdrafting or over withdrawal are happening. Okay, so a little bit about these pictures. What we're looking at is the water table dropping in an aquifer, and this happens from unsustainable overuse. The water springs no longer feed some of the streams, and shallow well owners no longer can reach the groundwater. So if you look at the 3 wells in both of these pictures, let's just compare them. So we have well to the left, middle well for the farm. Okay, so if the farmer is watering his crops and he draws on the groundwater and he does this in a sustainable way and does not use heavy pumping, then the water table will allow the wells to the left and to the right to have little problem with drawing water. Notice that their wells are slightly shorter than the farmer's well. So he has a much deeper well, which is also more expensive and, by the way, requires a lot more electrical energy in order for him to pump that water out of the ground. If the farmer, you'll see all those little white spots, those are not big flowers on his crops, that's actually sprinkler systems. So if he withdraws more and more water than what can be recharged in there, that this cone of depression forms from the change in pressure. And this cone of depression of him pumping and pumping and pumping, and it's actually going all the way down to the bottom of the depth of his well tap. Then the wells on the left and the right then become dry wells. They no longer can access that lowered water table. So you do need to understand that high and dry part with the cone of depression. And this is a result of overpumping, which happens a lot in agriculture. Okay, other effects of overpumping can also include contamination. So you can contaminate the water because the immense pressure that used to exist, that used to keep the salt water out. So you see where the salt water is? This usually happens in coastal regions. So contamination can include salt water. And it's not as high pressure. If we run out of that groundwater, we've withdrawn more and more of it. We don't have that pressure of the groundwater keeping the salt water away. So now the salt water has higher pressure. It can move on in, and when it moves on in, what it's doing is intruding on that fresh water. And that's why we call it salt water intrusion. Duh. So this only happens, remember, usually in coastal areas where people have access to groundwater, and it's also close to where seawater might be. So it just happens when the salt water is able to infiltrate the fresh water, and you no longer have that freshwater resource because it now has salt water in it. And salt water is not safe for us to drink. That will actually dehydrate us. So here are a couple more pictures actually from your textbook showing the same idea. You can pause, you can go backwards in this video. Notice where the well is. So we're just helping that salt water come in when saltwater intrusion occurs. Remember, this is now called contaminated water. So we do not want to contaminate our very, very precious resource of groundwater. Okay, other effects of overpumping and overusing our groundwater. We can actually dry up that area so much where there's no water maintaining the pressure to hold everything that's above it. If we can't hold everything above it, then everything's basically going to cause excessive weight on whatever's below. And then usually what's below is a cavern. And that underground, now empty and void of water cavern collapses. When it collapses, we get a sinkhole above ground. So at the surface, it's just collapsing because of that void where there was water. That water was maintaining the pressure, holding all the weight on top of it, and it is no longer there to hold the weight on top of it. So it's due to a loss of pressure from water drainage. Okay, make sure that you understand, how to use the terms withdrawal. Okay, just remember these things. Go ahead and read that. And then I'll go to the next slide. And you can pause and you can read these on your own. But these are some of our trade-offs. So we have advantages and disadvantages to withdrawing groundwater. So it's not of what is groundwater. It's of the act of withdrawing groundwater. Now you look at the advantages. Which one's an advantage to you of withdrawing the groundwater? You might be a well owner. You might be withdrawing from groundwater. What would be the most important thing to you? And then look at the disadvantages. What are the disadvantages of us withdrawing and using groundwater? Which one's the most important to you? And it really depends on where you live and what your water resource is. Where do you get your water from? Okay, now this is about prevention and control of groundwater depletion. So we all know from the opening pictures, this is becoming a major problem in the world, not just in the United States. So how do we prevent depleting of groundwater? Yeah, we all know we can waste less water. Take shorter showers. Don't keep running the water at the sink. Which one do you think would be easiest for you to use today for preventing groundwater pollution? Which one could you just start using today? Which one would you recommend to a farmer for preventing groundwater depletion? And let's say that you really can't control those things for prevention. What do you think is the best method for the right column, controlling groundwater depletion? So these are all good strategies that could come up on the AP environmental exam for groundwater prevention or groundwater control. Remember these as strategies and solutions. Okay, well, that's the end of our time together. That's the conclusion of part 2 for chapter 9. Please be sure to use the information from this to keep your footprint small. Have a nice day.
Hey, what happened to my water?
There's something here that you should know. The story of water from down below.
Oh, I'm groundwater, I'm all around. Most of your water is underground. The water we have is all the same. I'm used over and over again. I surrounded the castle with a watery moat, and I float along under Huck Finn's boat. I once stripped down as dinosaur drool, and now I'm the cool that fills your swimming pool.
Feel the drops of snow and rain, an age-old cycle again and again. Groundwater under the ground, groundwater flowing down in the ground. Groundwater all around, groundwater. Don't you know why we should care? The water we use is everywhere.
Riding along the aquifers, deep down under where no one stirs. I feed the lakes, streams and land. I'm pulled by wells, I'm in demand. Flowing along the great bear treasure, slipping through space too small to measure. I may start off with an oily sheen, but the dirty rocks help keep me clean.
Swallow and swim, shave and spray. We all use water every day. Some for fishes, some for dishes. But is there enough for everyone's wishes? Use it. Groundwater, don't abuse it. Groundwater, we use our groundwater every day. Let's make sure it's here to stay.
Oh, rainy days, I must lament the troubles I have with tar and cement. I can't feel the ground if I can't get through. I'm groundwater, my power is vast, but waste and pollution keep me from my task. If we're not careful, clean water won't last.
That's some help. We can't carry on. What will we do if the water is gone? Every time you brush your teeth, remember the water underneath. Next time, wait, stop, and think before you dump stuff down the sink. Do your part for water power. Learn to take a shorter shower. Stuff that makes your grass look swell will end up later in your well. Protect groundwater, conserve groundwater as we plan to build and grow. Leave open space for water to flow. Be aware, groundwater, show you care. Groundwater, now you are in the know. Don't forget the water down below. Don't forget the water down below. Don't forget the water down below.
I'm groundwater, I'm all around. Most of your water is underground. The water we have is all the same. I'm used over and over again. I surrounded the castle with a watery moat, and I float along under Huck Finn's boat. I once stripped down as dinosaur drool, and now I'm the cool